Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, I'm going to be talking about the addition rule. And yes, as it relates to probability. I hope you like my nice slide here. I think this is one of my favorite. Purple is one of my favorite colors. But just on a side note, let's get started. First, we need to define some terms. The first term I want to define is disjoint, which also can be described as mutually exclusive. And we say that two events are disjoint if they have no outcomes in common. So there's no overlap. There's nothing in common between two sets. Those are called disjoint sets. All right. And here's a little Venn diagram. So this is a Venn diagram that shows our sample space. So S stands for sample space. Everything inside of here is in our sample space. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all in our sample space. But then we have some subsets of the sample space. The first one is E, second one is F. E has 0, 1, 2 in it, and F has 8 and 9. There is nothing overlapping. There is no numbers that are in both E and F. And so therefore, we would say that E and F are disjoint sets. These numbers are different and separate. So they have nothing in common. So those are disjoint sets. And this is what a Venn diagram of disjoint sets will look like. If E and F are disjoint or mutually exclusive events, then we have a formula on how we can find the probability of E or F. All right. And we will find the probability of E or F by just adding the probability of E to the probability of F. All right. That's if you have disjoint sets. So it's important that you first know if your sets are disjoint or not, because there are two different rules, one for disjoint and one for sets that are not disjoint. Okay. So if the sets are disjoint, you will find the probability of E or F, or is important here, by doing the probability of E plus the probability of F. And they can be extended if you had more than one set. So say you had 3 sets, probability of E or F or G, you will just add all the individual probabilities together. Regardless of how many sets you have, as long as they're disjoint, you just add them together. Now, there's a general addition rule which applies to all sets, even if it's not disjoint. So typically when you have not a non-disjoint set, this is the formula you'll use. So now if you want to find the probability of E or F, not only do you have to add the probability of E and the probability of F, but you also have to subtract the probability of the overlapping portions of E and F. That's because this overlapping portion is counted twice. It's counted in the probability of E and it's counted in the probability of F. And so therefore you have to take one of those out, okay? So this is the general rule on how you will find the probability of E or F if the sets are not disjoint. And this is what a Venn diagram of two sets that are not disjoint would look like. So this rectangle represents the sample set. In our sample set, we have 6, 8, 5, 7, 9, 1, 3, 0, 2, and 4. In E, we have 5, 7, 9, 1, and 3. In F, we have 1, 3, 0, 2, and 4. And as you can see, E and F have 1 and 3 in common. So these are two sets that are not disjoint. So when you find the probability, you'll take the probability of E, you'll add it to the probability of F, and then you'll subtract it. You'll subtract the probability of this overlapping region right here, which is the 1 and the 3. So let's look at an example. All right, I have an example here. It has multiple parts, but we want to let S, our sample space, be the numbers, the set with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 in it. And then we want to let E be an event with the numbers 2, 3, 4, 5, 6, and 7. Let F be a set with the numbers 5, 6, 7, 8, and 9. And let G be a set with 9, 10, 11, and 12. So I have 3 different sets here, not including the sample set. I have 3 subsets of the sample space, okay? And I want to assume that each outcome is equally likely. So if I choose something from E, it has an equally likely outcome for each one, all right? So I want to answer the following questions. Are E and F mutually exclusive? That's the same thing as saying, are E and F disjoint? So I want to look and see, do E and F have anything in common? And yes, they do. Look, they have 5, 6, and 7. E and F have 5, 6, and 7. So they are not mutually exclusive. So we will say the answer here is no. I think my color is wrong. Let me change the color. All right. So yeah, so we will say the answer here is no. They're not mutually exclusive. What about E and G? Are E and G mutually exclusive? Are they disjoint? Do they have anything in common? And as you can see, E has 2, 3, 4, 5, 6, and 7. G has 9, 10, 11, and 12. They have nothing in common. So yes, they are mutually exclusive. All right. Now, what is the probability of E? So in order to find the probability of E, we need to know how many outcomes are there in E. There are 1, 2, 3, 4, 5, 6 outcomes in E. So we would say 6 divided by our total number of outcomes possible. And our sample set has 12 items in it. So it'll be 6 divided by 12, which if you divide that out, that is 0.5. So the probability of E would be 0.5. We want to do the same thing for F. What's the probability of F? Well, how many outcomes do we have for F? There are 1, 2, 3, 4, 5 outcomes for F, divided by the total number of outcomes in the sample space, which is 12. And if you do 5 divided by 12, you calculate that, you end up getting 0.417. All right, we also want to find the probability of G. For G, how many outcomes are there for G? There are 1, 2, 3, 4 outcomes for G. So you will do 4 divided by 12. If you divide 4 by 12, you end up getting 0.3333, repeating. And I'm just going to round this to 3 decimal places, and that's how you will find the probability of each of those. So next we want to find what is the probability of E or F. So in order to find this probability, we have to know if E and F are mutually exclusive, which we already said they are not mutually exclusive. So that means we will be using the formula that has the probability of E. We'll be using the general addition rule. The probability of E plus the probability of F minus the probability of E and F. So I need to know, I know the probability of E, I know the probability of F because we just found those. But next we need to know the probability of E and F. So I'm going to come over here to the side and just write out, my E and F set. So E and F will be the overlapping part of E and F. So if you look and see, what do E and F have in common? They have 5, 6, and 7 in common. So what will be the probability of E and F? And the symbol for and is an upside down U. So you may see that U sometimes. It's an upside down U that stands for and. That's the overlapping region of 2 sets. So there are 3 possible outcomes out of 12 total outcomes. So that ends up being 0.25. So the probability of E and F is 0.25. So now I'm going to come back over here to my calculations. We know that the probability of E is 0.5 because we just calculated that. So that's 0.5. We know that the probability of F is 0.417. And then we know that the probability of E and F is 0.25. So in order to find the probability of E or F, we would do 0.5 plus 0.417 minus 0.25. And we end up getting, once you calculate all of that, you get 0.667. So that would be the probability of E or F. So we did the probability of E, which is 0.5, plus the probability of F, which is 0.417, minus the probability of E and F, which is 0.25, and that ends up being 0.667, all right? There's one more part for us to do, and that is, what is the probability? Well, there was one more. The slide is missing. Let me see. Did it get out of order? Oh, I must have deleted a slide, y'all. I'm sorry, but I'm going to go ahead and do it on this one. The other part I had was for us to do the probability of E or G. I don't know what happened to it. It disappeared. So let's just say there was a G there. And in order to find the probability of E or G, we need to first know if E and G are mutually exclusive, and we know that they are because we answered that question previously. So that means in order to find the probability of E or G, we would just do the probability of E plus the probability of G, because this is the addition rule for disjoint sets, mutually exclusive sets. So we know that the probability of E is 0.5, and we know that the probability of G is 0.333 because we calculated that previously. And we will add those together and it will give us 0.8. It will give us 0.833. So that will be the probability of E or G. Now for this last example, it says a survey was conducted in which adults were asked whether they use social media or not. And these are the results in the chart right here. Our first question is, if an American adult is randomly selected, what is the probability he or she uses social media? So in order to find that, we need to know the total that uses social media, which would be this top number right here, 338, divided by the total number that were surveyed, which will be this bottom number right here, which is 530. So if you divide that out, round it to 3 decimal places, you end up getting 0.638. So the probability that the next randomly selected adult will use social media is 0.638. If you talk about that as a percentage, that's approximately 63.8% that person uses social media. The next question says, if an American adult is randomly selected, what is the probability he or she is between the ages of 35 and 44? So here in this column, these are our 35 to 44-year-olds. There are 125 of them. So we would do 125 divided by the total number surveyed, which is 530. 125 divided by 530 is 0.236. So that will be the probability for that portion right there. All right, and then the last two parts is, if an American adult is randomly selected, what is the probability he or she is a 35 to 44-year-old social media user? So now we want to know the overlap, that they're both 35 to 44 and they use social media. So remember, here's our 35 to 44-year-olds. Only 89 of them use social media. So we would do 89 divided by 530. And so round that to 3 decimal places, and that gives us approximately 0.168. So that will be our probability for that portion. And then the very last portion is, if an American adult is randomly selected, what is the probability he or she is 35 to 44 years old or uses social media? The key word here is or. So we would take the probability of them being 35 to 44 years old. So remember, we're using our formula P of E plus P of F minus P of E or F. And F. That's the formula we're using. So the probability that he or she is 35 to 44, we just found that in part B. That was 0.236. And that'll be plus the probability that he or she uses social media. We found that in part A, that's 0.638. And then we will subtract the overlapping region that he or she is 35 to 44 years old and use social media. We found that in part C, which was 0.168. So add all that together and subtract that, and you end up getting total 0.706. So that will be your answer for the probability of 35. A person that is randomly selected is 35 to 44 years old or uses social media. And so this is how you will use the addition rule in different contexts. If you have any questions, please don't hesitate to put those questions in the comments. And thank you for watching. I will see you in the next video.